So today we're going to cover section 4 of chapter 4, and today we're going to complete the square. So these are the steps for completing the square. What you want to do is keep your x squared term and your x term on the same side of the equation, and then you're going to move your constant to the other side. Remember, before we used to just shift it over, but now we're actually going to move it to the other side. So now there's no confusion of do you add the opposite or what? We're just doing the same thing to both sides of the equal sign when we add that c term, which is the b divided by 2 squared. And then again, we're going to complete the square. Now, on the ellipses and the hyperbolas, we're actually going to complete the square twice within one problem. So let's go ahead and let's try to do this. Again, these are the steps. You can read through them if you want to do it, but I think it's better if I just do the problems. So one thing that you can look at is, or notice, that whenever there's only one variable that's squared, that should be a clue that it's a parabola. Now, before when we completed the square, we didn't have a y squared. It was just the x squared because it was up, just the vertical parabola, the up and down. So again, my first step is going to be to move the constant to the other side. And I need to get my variable that's squared with its also same variable, the y, on the same side. So let me just move the 3 over. And now I have y squared minus 6y. I'm going to leave a blank space equals x minus 3. Now, the part that I'm completing the square for is this right here. So what I need to do is take my b term, which is going to be the negative 6 here, divide it by 2, and square it. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So again, what I like to do here is don't put in here as a plus 9, but technically that's what it is. What I like to put in here instead is what it was before I squared it. So I'm going to put it in as negative 3 squared. But over on this side of the equal sign, I am putting plus 9. Now I need to factor this trinomial. And again, the reason why I leave it as negative 3 squared, this tells me the binomial that it becomes. I just take what was here and put it right here. And then now I have to do the math on the other side. I need to combine my negative 3 and 9, and then this becomes x plus 6. And now I have it in the standard form. And I'm done. Now, what you're also going to need to do is now go back and apply everything we did in 4.3a. We need to find the vertex, the p-value, the focus, the directrix, and then you're going to have to graph it. So again, this is in the form, so we've already got it in the standard form. So we can see the vertex is right here. This is K. This is H. So my vertex is going to be equal to negative 6, opposite of what you think it is, comma 3. Now, remember the p-value, if you want to put parentheses around this, you can assume that there's a 1 here. So to find your p-value, you're going to take this 1 and you're going to set it equal to 4p. Now remember, this equation was y minus k squared equals 4p x minus h. That's what this thing is. Now, I need to find the value of p, so I divide by 4, and I get p equals 1/4. Now, my axis of symmetry, you'll have to find that. So axis of symmetry, remember whenever it's a y squared, the axis of symmetry is that variable squared, and it's equal to the y coordinate of the vertex. Now, for the focus in the directrix, this is where we use the p-value. So for your focus, we're going to take that vertex and we're going to add p to the non-squared variable. My non-squared variable was x, so I'm taking -6, my vertex, I'm adding p to it, which was 1/4, comma 3. So -6 plus 1/4 is going to be -5 3/4. If you want to show it as an improper fraction, -23/4, comma 3. The directrix is the opposite of p. So for the directrix, and let's see, let's do a different color, directrix. So again, the non-squared variable, and now I'm going to add the opposite of p to the x of the vertex, and the opposite of p is -1/4, so my directrix equation is -6 1/4. If you need it as an improper fraction, -25/4. Now, this is everything that you did on the quiz. The only thing that was new was this part over here where we completed the square. Now, I'm going to take all this information and put it on the graph. Here's my axis. I'm going to go ahead and graph my vertex. 1, 2, 3, 4, 5, 6. 1, 2, 3. So my vertex is right here at -6, +3. And then my focus point, do that in purple, it's the -5 3/4, comma 3, so it's really close. My directrix was the equation x equals -6 1/4. So my directrix is right here. And now remember, when the center was not at the origin, we needed to find an additional point. So for this one, I can either find my x or my y-intercept. Let me go ahead and find my x-intercept. I'm going to set y equal to 0 into my original equation, which was y squared minus 6y plus 3 equals x. So 0 squared, 6 times 0 plus 3. Notice this is all gone. So then you're just left with 3 equals x. So 3 comma 0 would be your x-intercept. So if I come over here, 1, 2, 3, I can put my additional point right here. I can use my axis of symmetry here. And since it's 3 away down here, I could go 3 away up above, 1, 2, 3, and show that it's going to be right here. And then connect your points and make your parabola. So the purple was the focus. Taking this into WebAssign, it may want you to put the focus and the directrix as an improper fraction. So just pay attention to that. Remember, whenever there's only one squared variable, we're going to be completing the square for a parabola. Remember, for the ellipse, it's got the plus sign. So both your x squared and y squared are going to be positive. For the hyperbola, that's the equation with the subtraction sign. So let's try the next example. Notice both my x squared and y squared terms are both positive. So this should be a clue that I'm going to be completing the square for an ellipse. Now, for the ellipse and for the hyperbola, we're going to have to do completing the square for both variables. I'm going to group my x's together and my y's together, and then from there move the constant to the other side. So what I'm going to do here is move the 9 to the other side. I'm also going to put my two x variables side by side, and then I'm going to put my two y variables side by side. So I can go ahead now and rewrite this as x squared plus 6x. I'm going to leave a little blank space. Then I can put plus 4y squared minus 8y, leave a blank space, and then it equals the constant that I moved to the other side. So now really what I'm doing here is completing the square for the x's and completing the square for the y's. So for the x's, remember when you complete the square, there can't be a number in front of x squared. So x's are good. We're ready to go. Take the b term, divide it by 2, and square it. So 3 squared, and I get 9. So again, what I put in here is plus 3 squared, because it helps me when I go to factor that trinomial. But over on the right side of the equal sign, I'm putting plus 9. We're not doing opposite signs. We actually moved it to the other side. So we're keeping the equation balanced by adding 9 to both sides of that equal sign. Now I'm going to do the same thing for the purple. However, for the purple, there is a number in front of y squared. So I need to factor out the 4 first. So then it becomes y squared minus 2y, and I'm going to leave a blank space. So now I take the b term, which is negative 2, divide it by 2, and square it. This gives me negative 1. And I square it, and it's positive 1. So again, what I'm going to fill in here is going to be plus negative 1 squared. But on the other side of the equal sign, remember you got to take the 4 you factored out, times it by the 1. And what we're really adding here is plus 4. So now I'm going to factor the blue. This becomes x plus 3 squared. The purple becomes 4 times y minus 1 squared. And then I can add these up. Negative 9 plus 9 is 0. So I set it equal to 4. Now, the standard form must be set equal to 1. So now I need to divide all 3 pieces by 4 to make it equal 1. So now the first fraction becomes x plus 3 squared over 4. The purple one, the 4's simplify. So I'm just left with my y minus 1 squared equals 1. Now remember, this, when you go to get your a squared and b squared, know that that is really an assumed 1 there. But when you go ahead and key it into WebAssign, you don't have to put the 1 that's there. So now, same thing that we just did on the quiz, we're going to pull out the center, we're going to find the vertices, we're going to get all the components so we can graph here. So if it helps you to see that this has got a 1 underneath it, because now we have to take this a step further. So here is H, here is K. So my center point is the ordered pair opposite of what you think. So it's negative 3, positive 1. Now here, my a squared is 4. It's the bigger number. So a squared equals 4. B squared equals 1. So a equals plus and minus 2 after I square root it, and b equals plus and minus 1. We need to find the c value for the focus. So we're doing c squared equals a squared minus b squared. I'm going to plug in a, which is 4. A squared is 4. B squared is 1. C squared equals 3. So c equals plus and minus the square root of 3. Now I'm going to use the a value to find my vertices. So for my vertices, I'm going to be taking the center point, so the negative 3, And because my a squared was under the x squared, this is what I'm going to be adding and subtracting the a value to the x coordinate, or the h. And then the center was comma 1. So I have a center at -3 minus 2 comma 1, -3 plus 2 comma 1, so -5 comma 1, and -1 comma 1. These are the vertices. Again, same thing that you had to do on the quiz. Next thing I can do is I can find my covertices. And again, I'm going to take that b value now, and I can add that to the k. So it'll be -3 comma 1 plus or minus 1. So -3, 1 minus 1, -3, 1 plus 1. So -3 comma 0, and -3 comma 2. Those are the covertices. Now I need to also find my foci. So again, it's on the same as the vertices. So again, I'm taking my center, -3, and then I'm going to add and subtract √3 to the h. So I have a foci at -3 minus √3, comma 1, and -3 plus √3, comma 1. Now, the square root of 3 is about 1.7. So here what I can do is -3 minus 1.7, and this will give me -4.7, comma 1 that I would graph. Now, when you're listing this on the line on the test, I want you to list it with the radical, okay? But for graphing, you would approximate it. So -3 plus 1.7, comma 1, and then this will give me -1.3, comma 1. Those are the foci. Now I'm going to take all 7 ordered pairs, the 2 vertices, 2 covertices, 2 foci, and the center, and put it on my coordinate plane. So here is my x and y axis. I'm going to graph the 2, I'll graph the center first. My center was at 1, 2, 3, let me just 4, 5. So my center point is at -3, positive 1. I've got a vertice at -5, positive 1. I've got another vertice at -1, positive 1. And then I have my covertices at -3, comma 0 and -3, comma 2. Now I can connect the red and the blue, make my ellipse shape here, and then I can also put in my 2 foci. So the foci are going to be really close to those vertices. Again, approximate it. And there is your graph for your ellipse after you completed the square. Next, we'll do a hyperbola. And again, remember the hyperbola equation has a subtraction sign. So on the next slide, notice my x squared and y squared have opposite signs. So that should be a clue that when I complete the square, it's going to turn into a hyperbola equation. Now again, we want to group our y's together, group our x's together, and move the constant to the other side. So I'm going to subtract the 16 and move it to the other side. And then I'm going to put the 2 x's side by side. I've only got a y squared, so that's okay. So let's watch what's going to happen here. So I get 4x squared plus 8x, leave a blank space. Then I'm going to write the y squared term, and then I can leave a blank space, equals -16, because I moved the constant to the other side. Now I'm completing the square here and here. Yes?
How would you know if it's a hyperbola again?
if the signs on the squared terms are opposites. Does that make sense? So you see how x squared was positive 4 and y squared was negative 3. All right, I need to complete the square for the x's. Again, remember the number in front of x squared must be a 1. So I'm going to divide out a 4 first. And then I'm left with x squared plus 2x, still leave the blank space. Same thing here for the y. I'm going to factor out a negative 3. And then I'm left with y squared. I can leave the blank space, negative 16. Now for the blue, again, you take the b term, divide it by 2, and square it. So 1 squared. So in here, I'm going to put plus 1 squared. Now for the other side of the equal sign, I take the 4. I should have been adding a 1, but because I factored out the 4, what I'm going to be putting there is plus 4. Now for the y, notice there's no b term. So there's really nothing here to be adding. I don't want to put a plus 0. So when I go to factor this, if you want to see it as, it's really negative 3. Let's see, maybe I'll just put a minus 0 here. All right, so now for the blue, when I go to factor this, so there was nothing to add to the other side, because negative 3 times 0 is 0. So let me factor the blue. 4, and then again, the reason why I put it in here, it's plus 1 squared. Then for the y, negative 3, y minus 0 squared. And then now I need to do the math here, and this becomes negative 12. Good so far? All right, next, what we need to do is set the equation equal to 1. So I need to divide all 3 fractions by negative 12, because I need to make this negative 12 a 1. So I'm dividing it by itself. I need to do that, though, to all 3 pieces here. So then now this becomes, when I divide, x plus 1 squared over negative 3, this becomes positive y minus 0 squared over 4 equals 1. Now, I want this set up so it's got the subtraction sign. I don't want a negative denominator there. So really what I can do is, instead of writing negative 3 here, I would have put the negative sign in front. And now I'm going to switch these, because I'm going to treat this negative sign as a subtraction. So now what I should have written first is the y minus 0 squared over 4 minus the x plus 1 squared over 3 equals 1. I'm switching the order here. Now, for the first one, I don't need to show the minus 0. So this should just be y squared over 4 minus the x squared plus 1, or x plus 1 squared over 3 equals 1. Now, before I pulled the 0 out, remember this is k, this is h. I need to pull that out from my center. Now, you're done with completing the square. This is the standard form. Now what we're going to do is find all the parts and then graph it. So this was the 4-3E homework. So let's go ahead now and pull everything out. So I have my center at the order pair, h and k up there, negative 1, negative 1, 0. Now, remember, in the hyperbola, a squared is always first. So my a squared equals 4. My b squared equals 3. I need to also find c squared, and I use the formula a squared plus b squared. So I can go ahead and plug in 4 plus 3, c squared equals 7. So c is equal to plus and minus the square root of 7. Now, for the vertices, remember we're using the a value, and my a value is plus and minus 2, and then b is plus and minus square root 3. So for the vertices, we need to go ahead and add the a value, and we're going to add that to the y because that's the variable we saw first. That's the axis that our graph is going to transverse. So for the vertices, I'm doing h, comma k, plus and minus a. That's how I can get my vertices, because this is the axis that the graph will transverse. So my -1, and then I'm going to do 0, minus 2, and -1, 0, plus 2. So I have a vertice at -1, -2, and -1, positive 2. For the foci, I'm going to go ahead and same variable that I add a to, I'm also going to add the c value. So I'm doing h and then k plus or minus c here. So then this just becomes -1, and then it's just the same number. It'll be negative root 7, because I'm adding it to a 0. And then -1, positive root 7. These are your foci. Now, we also need to find our asymptotes. This is a hyperbola. Now, remember, whenever your graph transverses the x-axis, the equation we're using for asymptotes is y equals k plus or minus a over b, and then x minus h. So again, I can plug in my information. My k was 0. So really all I'm doing is a over b. My a is 2. My b is the square root of 3, plus or minus, and then x plus 1, because my h value was -1. Those are my asymptotes. Now, what I'm doing here is square root of 3 again, if you think about it, is between the perfect squares 1 and 4. Square root of 1 is 1, square root of 4 is 2. It's closer to the 4, so I'm going to say square root of 3 is about 1.7. So over here, my slope that I'm going to move from the center, I'm going to rise to, and then I'm going to run approximately 1.7. And again, this is an estimation. Just get it as close as you can. So we're going to move the slope, or we're going to use the slope, and we're going to move the slope, rise and run, from my center to graph the asymptotes. So I'm going to be graphing the vertices, these guys. I'll be graphing the foci, and then I'm going to be graphing this asymptote. So let me go ahead and make my axis. I'm going to graph my center point. My center is at -1, 0. And then from this center point, I'm going to go up 2, and then over almost 2, it's 1.7. So again, it's an approximation. So from there, rise 2, and then run almost 2. And then I can go down to, and this would be the location of my asymptotes. And now what I can do is go ahead and graph the vertices. -1, +2, -1, -2, And again, use the asymptotes as your guide to make your hyperbola. And then also graph the foci. So again, I'm graphing -1 and about -1.7. So about here and about here. So the purple are the foci. And there's your hyperbola graph. I'm going to do another parabola for you. And if I can get to the next one, I will. If not, there is a video now. I've done one of each. Be able to do any of these for the test. And then take your standard form and then answer the questions to get the graph. So let's try another parabola, example 4. Notice there's only one squared variable. It's the x. Now, what I like to do here is I want my square term to be positive. So I'm going to first start out by just dividing everything by -1. So I'm going to change this to x squared minus 10x minus y plus 21 equals 0. Next thing I need to do is move the constant to the other side and make sure my x, and also move the y to the other side. So I'm actually moving the y and the 21. So whenever it's a parabola, you're keeping this squared variable and its non-squared component or part together on one side, and then the variable that's not squared moved to the other side with the constant. So I'm really adding y and subtracting 21 from both sides. So it's gone from the left side. And now I'm left with y minus 21 over here. Now, I need to complete the square. So I take the b term, divide it by 2, and square it. So -5 squared. And that's what I'm going to put in here. But over here, I'm actually going to put plus 25. And let's see, I shouldn't have put parentheses around it yet. So I had the y minus 21. And now I'm going to add the 25 that I got when I took the b term, divided it by 2, and squared it. Now I can factor this side. It factors into x minus 5 squared. And then here I got to add this. -21 plus 25 gives me +4. And there's your standard form. Remember, this is k. This is h when I go to pull out my vertex. So the standard form, we stop here. This is what you would write on the line. But now we got to answer all the questions. So the vertex is your h and k. So I pull it out opposite signs. So 5 and -4. I also need to find my p-value. Remember, the p-value is what number would have been right here in front, and there's nothing there, so I assume it to be a 1. So I set 4p equal to 1, divide by 4, and p equals 1/4. Remember, we use that p-value to find the focus. We're going to add p to the non-squared variable of my vertex. My non-squared variable was y. So again, remember, not only is this hk, it's also xy. So I'm going to be adding p to the y to get the focus. So for my focus, 5 comma, and then I'm doing -4 plus 1/4 to get my focus point. And when I do this, I get 5 and then -3 and 3/4. And then if I wanted to make it improper, I could have also said this is 5 and -16. No, that's wrong. Over 4. And then for the directrix, it's the opposite of p. So for my directrix equation, I'm taking the non-squared variable, which is y, and I take the y of the vertex, which is k, -4 opposite of p, so it's -1/4. So my directrix is -4 1/4. If I need to make it in an improper fraction, -17/4. Now I also have to list my axis of symmetry. So it's the variable that's squared. So that's going to be x equals, and it's the the h of the vertex. So now that I have all this information, now I can graph my vertex, my focus, my directrix. I think that's it. Let's see. So here is my x and y axis. My vertex is at 1, 2, 3, 4, 5. 1, 2, 3, 4. -5. I'm sorry, +5, -4. That's the vertex. And then I can go ahead and graph my focus, which is at +5, -3 3/4. I can graph my directrix, which is the equation -4 1/4. So right here. What I'm going to do is find, since my center is not at the origin, I need to find an additional point. So let me go ahead and find my y-intercept. You could also find an x-intercept, but let me do the y-intercept. I'm going to set x equal to 0. So in my original equation, or you could use your standard form, it doesn't matter. So 0 squared, 10 times 0, plus y minus 21. This is all gone. Y minus 21 equals 0. Add 21. And y-intercept is at the order pair 0, 21. So it's actually going to be somewhere way up here. So when you go to make your graph, you could have labeled that as 0, 21. You can use your axis of symmetry and then see that this is 5 spaces away on this side. So 1, 2, 3, 4, 5. Go out that way and then put 1 across. Again, the key thing I'm looking for is that you've calculated everything correctly and you wrote the right answers on the line. So this would be another example of a parabola. I can do another parabola for you. That would be example 5. And I'll go ahead and do number 5. Again, I only have one squared variable. So what I'm going to keep on the left side is the variable that's squared, and then the other variable that is the same letter. Then I'm going to move the x and the 49 to the other side. So what I can do here is I'm going to divide everything to get my squared term positive. Let me divide everything by -1 first. So 2y squared minus x positive 20y plus 49 equals 0. So now I need to move the x to the other side and the 49. So now I'm left with 2y squared plus 20y, I'm going to leave a blank space, equals the x minus 49. I need to complete the square. However, remember the number in front of the square term has to be a 1. So I divide everything by 2 first. Y squared plus 10y, leave a blank space, and then I still have the x minus 49 over here. So now I need to take the b term, divide it by 2 and square it. So 10 divided by 2 is 5. 5 squared, 25. So in here I'm going to put plus 5 squared. But for the other side, remember you take the 2 you factored out, multiply it by the 5 squared, which was 25. And what I'm adding to the other side is 50. And then now what I can do is factor the blue, becomes y plus 5 squared equals x plus 1. Now, I don't want a number. I need to isolate the y squared, so I need to divide both sides by 2. And my final standard form here is going to be y plus 5 squared, and then the divide by 2 is really a half, and x plus 1. Because I need this half to set it equal to 4p. So that's the new part, the completing the square. Then from there, what you're going to do is answer all the questions. Find the vertex, focus, directrix, the additional point, and then graph it. There is a review that's already posted with the solution file. Test is Friday. Again, watch the video. If you need more additional examples for completing the square, there is a second video that has 5 through 10 worked out.